Okay guys, so like I promised, I'm going to create a 9-week kind of review video. I'm going to go over obviously the Unit 3 quiz, okay? And it's also going to help you with the file titled DCA. So the DCA, just super quickly, it is given to all the math teachers by the district. Okay, district. So I do not write this test. I just want you to do your best. This one I wrote, but the DCA I did not write. So just do your best on the exam titled DCA on Schoology, and but I am going to actually go over like all the topics that the DCA asks you about in this video. So just bear with me. It's just going to be like last time, to where like I hop around and do like different problems. So let's start with number 1. So number 1 says the graphs of the equations 4x minus y equals 6 and x plus y equals 4 intersect at the point whose coordinates are A, B, C, or D. So all it's telling you to do in too many words is set up a system of equations. Okay, so if you've been in my class, you should remember system of linear equations. Okay, and you just line them up. So it should look like this. Equals 6 lined up with x plus y equals 4. And so the goal is to find x and y. So that's why they look like coordinate points, because that's the x, that's the y, that's the x, that's the y, x, y, x, y. Okay. Whatever. Okay, so if you guys remember, so I'm just going to go ahead and work out. I'm going to go ahead and I'm going to solve number 1 to give you guys a good example. So where do I want to do that? I'll do it here. So 4x minus y equals 6, and then, but I want a blank piece of paper. Can I add a paper? Can I add? I don't think I can add. Oh, whatever. Okay. I'm just going to erase it then and start over on a blank system of equations. Alrighty. So remember, the goal is to pretty much isolate one variable to be able to plug it into the other one. Okay, so in other words, substitution. So we're going to substitute one equation into the other. I like this equation just because it looks pretty and it looks simple, so I'm going to use it. So it says x plus y equals 4. Okay, so just very, very quickly, I can easily isolate x by moving y over on both sides to make it x equals 4 minus y. Okay, so what I just did, I just isolated x. I just picked whichever one, you can pick either one, and isolate x or y, just by moving something over to the other side, by keeping it balanced. And so y minus y would be 0, and then since you can't combine these because this is a number and this is a letter, they just go side by side like that. So what I'm going to do now, I'm going to take, because remember the goal is to find two answers, x and y. Aren't you erasing? Oh my gosh, it's not erasing. Okay. Gosh, why aren't you erasing? So I'm going to rewrite the equation. I'm going to plug this to here, into the other one. Go all the way. So now, go back. Okay. So now my problem looks like this. For parentheses, x, but x is 4 minus y. And then don't forget this minus y also. So another minus y equals 6. And so now I'm going to solve. So that becomes 16 minus 4y. So we distribute. That's 16. That's negative 4y. And then that just drops. Minus y equals 6. And now I'm going to solve for y. So that's actually 16 minus 5y equals 6. Minus 16 minus 16. So that's 0, that drops, and that's negative 10. Kind of all over the place. And now I have negative 5y equals negative 10. And so I divide by negative 5 to get y equals 2. Okay. So looking back at my answer choices, I can eliminate a few. Y has to equal 2. Okay, so it's very quick to see how you do. So obviously the answer is D, but you need to see how I solve for x, okay? So I just solved for y, which is here. That's what I just did. So now I'm going to go back to my original equation, okay? My original setup. And again, I'm going to pick one that I like. And I still like, that's still my favorite one. X plus y equals 4. But we just figured out what y was. Okay, so I'm going to rewrite it. So the original problem, we gave it to us. It said x plus y equals 4, except we just figured out what y was, which was 2. Subtract 2 from both sides. Oh, don't have any room. So obviously x equals 2. So the idea is to isolate for one variable and then plug that equation that you found, that isolated equation, into the other one to solve for two variables, x and y. Okay? Oops, sorry. So that's kind of how to do problems that look like number 1. I'm sorry I wrote over it. But so number 2 is, oh look, number 2, they were nice to you. Look how they said, they isolated it for you. Look how nice they were. And so you would just plug this into whatever y, which is what they said, y is x plus 1, that would go here. Okay, and then so it would be x, so y plus x equals 3. That's really just x plus 1 plus x equals 3. And then you solve for x, and then you use x to solve for y. Okay, so I even set it up for you. Well, okay, moving on. Moving on. Exactly the same. Number 3, exactly the same. Number 5 is exactly the same. Number 6, exactly the same. Very straightforward. You just plug one variable into the other. See, here they isolated it for you. No, not that. Look, there. Oh my God, are you serious? Okay. They isolated x. They said x is actually negative y. So I'm going to use this. I'm going to plug it into wherever you see x. Okay. So they said x is negative y. So I'm going to rewrite the second equation now. I'm just rewriting it. But I'm going to replace, okay, so it's actually negative y, kept everything else the same, plus 2y equals 6. Combine like terms, and negative y plus 2y, that's just one positive y. So y equals 6, guys. Okay, y equals 6. You can obviously eliminate all of them, actually. Okay, I hope they're not all like that. This one, I feel like that's self-explanatory. Number 8, they're just telling you how to set up the problem. Like, you don't actually have to, like, solve it. They want to know the setup. But to set it up, remember, you have to isolate something first. Okay? You have to isolate first. So if I were you, I would work on getting this negative y. Well, really not that negative y. Isolating this y. It's going to be a little challenging, but you can do it. And then after you isolate y, you plug whatever y actually turns out to be, you would plug it into the other equation, and it's just asking you to set it up. Okay? You can eliminate two answer choices really easily just by looking at it. You know, like, where y is supposed to go. Okay, question number 9. It looks like a lot, but really, you just have to read. Okay? And all I'm asking you to do is to pick the setup that makes the most sense. Just read. Like, it's not hard. It's really, like, there's actually no math, no actual, like, solving involved. You just have to pick, like, the right setup that makes the most sense. Once you read it and you see what the answer choice is, like, I won't even have to, like, it's that easy. Okay, same thing, number 10, literally just read the problem and pick the best setup that matches the problem. So no solving on number 10. Same thing, number 11, no solving. Number 12, you're not actually doing anything. Okay, you're picking the one that makes the most sense, that you think makes the most sense. 13. Let's talk about 13. Let me actually do it. I'll do 13. So, they want to know what z is. And so the way to do this is to just substitute kind of over and over again, one into the other, like back substitution. It's called back substitution, honestly. But here we go. So they said x is equal to z plus 2. And then they said y is equal to 3z plus 4. So they were nice to us, guys. They isolated x and y for us. So what I'm going to do, it's really, really simple. I'm going to change colors, first of all. What I'm going to do, x is blue. Oops. Y is green. Okay, be careful now. Literally, and they didn't give us z, so I'm just going to leave it alone. But they want to know what z is. So now I am going to substitute, okay, everything into the very first equation. So watch what happens. So they said x is z plus 2. So first, I'm going to just rewrite this the original first equation. Okay. Except colors. I'm going to use colors. What I'm going to do now, x, they said, is z plus 2. Plus y, would they say y was 3z plus 4? And then plus z equals 1. So now I'm going to combine my like terms. So my letters, combine those, and then my numbers, positive 2, and positive 4, and then I'm just going to leave that 1 alone on the other, so I'm going to leave it alone for now. So how many z's do I have? I have 1z, plus 3 more z's, that's 4 z's, so I have 5 z's. 5 z's, and then 2 plus 4 is 6, equals 1. Yeah. Oh my gosh, can I just like move over? So now I'm just going to solve for z. And so remember, the question actually is asking for what z is. It's not asking for x or y, it's asking for z. And so it's really simple now. Just solve for z, subtract 6 on both sides. That's 0. Drop the 5z. That's negative 5. So now I have 5z equals 5. Last step, divide by 5, because I want to get rid of that. So that becomes 5 divided by 5. That's just 1z, also known as z. Then over here, also 5 divided by 5, which is 1. So z is 1. Okay, so that's what I mean by substitution, is defining something or isolating something, plugging it into another equation, and then solving. Okay, so it looks ridiculous, but it's not. Okay, so this is the same, exactly the same setup. Maybe just like a tiny bit with like one tiny like detail difference. But, and then 15, it is literally like there's no solving or anything. You may have to do a little critical thinking, but again, it's just you matching the answer choice with what data they give you. Okay, so that's the whole test. So reminder, guys, this, what I just went over, the Unit 3 quiz, Unit 3 quiz is due Thursday. What did I say? Thursday? Yeah, I should have said either. Whatever. Thursday at 11:59 p.m. Thursday, I think that's, well, this Thursday, the end of the 9 weeks. That's really it, guys. There's a Google form for it. Make sure to, oops. Sorry. Make sure to turn in the Google form before it closes. I'm going to close it Thursday at 11:59 p.m. Okay. So now let's move on to the DCA. So I don't actually have the PDF in front of me, but what I can do is I can talk about all the topics that they're gonna ask you about. Okay. So here we go. Actually, wait, let me... remove... Nah. There we go. Make a new file. Grid paper. Okay, here we go. Okay, so this is help on the topics. The exam titled DCA. It is on Schoology. 25 questions. It is timed. Okay, they put a timer of 2 hours on the test. It is also multiple choice. Okay, another thing. It is, yeah, you can only take it once. Okay, I am going to classify it as a single daily grade. It is not the end of the world if you don't make 100 on this test. Okay? It's going to be all right. Again, I just want you to try your best. Okay, so topics on this test. Today in class, like in face-to-face class, we talked about absolute value. Okay, that is on this test. What we just did with systems of equations is on the test. domain and range on the test, and finding inverse functions. Okay, so since I just went over this, I literally just went over that. Okay, I just went over systems of equations. I have a video on domain and range. Okay, so there's a YouTube video that I made for domain and range. Okay, so I am going to talk about absolute value. Okay, so this is going to be absolute value. Inverse functions. I have a video for that. I made it weeks ago. Watch the video, inverse functions. Okay, YouTube video for domain and range, and another YouTube video for inverse functions. And I just talked about systems of equations. So what I'm going to talk about now is absolute value. Okay. So here we go. Absolute value. Okay, so the need to know. So this is these vertical bars. It's a math symbol, okay? Math symbol alert. This is referred to as the absolute value of any number x. So x can be any number. X can be positive, x can be negative, x can be 0, x can be a fraction, a decimal, whatever. X can be anything. And so the thing with absolute value is anything that has these bars, the absolute value of anything, I'll write that down, the absolute value of anything is always positive. Very, very simple. So today in class, I had 3 examples. Okay, say if I have the absolute value of 4 with these bars, my answer is just 4. Now, here's where the magic happens. Absolute value of -5. The power of absolute value. Anything inside becomes positive, so your answer is just 5. And now we have even a different example, -6. So a negative on the outside and a negative on the inside. So the absolute value of -6 is 6. But there's another negative on the outside. So they said, oh, wait, make it negative. So actually the answer is -6. And that's really what it is whatever you put in there, it's always going to spit it out as a positive. So let's get going. So let's do some examples. So say I have x plus 6 equals 20. So there's 2 parts. Part 1 part 2. So part 1, this is the setup, x plus 6 equals 20. This is the setup for part 2, x plus 6 equals negative 20. Notice, the first thing you should notice, there are no bars, okay? There were bars here. Oops, I want black. There are bars here in the original problem. But when I get into the what I like to call the two-part format, okay, the bars they're supposed to be here, I dropped them. Okay, so that's the first thing. On both sides, I dropped the bars. Now, the only difference between part 1 and part 2, it's not the left-hand side. You should notice that nothing on the inside is actually ever going to change. That stays the same. The left-hand side stays the same no matter what, part 1 or part 2. In part 1, I kept it positive just like it was. In part 2, the only difference is I made it negative. I made the right-hand side negative. But everything else stays exactly the same. And so at this point, now what I do is I just solve for x, just like normal. So x plus 6, I'm just going to rewrite it, equals 20. Subtract 6 on both sides, I get 0 over there. 14 here, x equals 14. Part 2, exactly the same. I'm just going to rewrite it. X plus 6 equals negative 20. Subtract 6 on both sides. Drop that. X equals negative 26. Okay. So, part 1, part 2. Every absolute value question has a part 1 and a part 2. Let's see here. Let's go to the next page on absolute value. Let's do another example. Example 2. Let's do 3 examples. Say I have the absolute value of x minus 5 plus 10 equals 50. So before I go to the two-part format, I have an important step in the beginning, and that is to balance it out before I go to the two-part format. Okay, so notice what I did. That's 0. Notice I have not touched this yet. Okay, that's going to drop. 50 minus 10 is 40. That stays the same. So now my problem becomes absolute value x minus 5 equals 40. Now at this point, now that you've balanced it out and subtracted 10 on both sides, now we can do the two-part format. Now the two-part format. Okay, and so I'm going to break out my, so this is part 1. Part 2 over here. Part 1 over here. Watch, so I'm going to write part 1. Write it with me if you feel like you got it on your own already. But now it just looks like example 1 now. So now drop the bars. X minus 5 equals 40. Part 2. Lots of students just forget about the second part just because they don't set it up like this in the beginning. But you always want make this negative. That's the key in part 2. Make it negative. Now I solve like normal. Solve for x. Add 5 both sides. That's 0. That drops. That's 45. Part 2 now. Add 5 on both sides. That's 0. That drops. X equals negative 35. Okay, so before you go, when problems that look like this, with a number that sits like on the outside, like that 10 is, you need to balance it out first, okay? Make it look like this with nothing else like sitting around those bars. And then you go to the two-part format, okay? And then you go to the two-part format. I'm going to do another one, last one. Example 3. Say I have 2x plus 4 minus 3 equals nah. Hmm. 17. Yeah, 17. Just made it up. Okay, so stay with me. First thing I want to do, balance it out. Make that 0. That turns into 0. That turns into 20. This I haven't touched yet, so it just stays how it is. It drops. So now I have 2x plus 4. Remember, don't forget those bars because that hasn't changed yet. Now we have 2x, absolute value of 2x plus 4 equals 20. Now the two-part format begins. Okay, so part 1. Part 2. So I'm going to set up my part 1. Really, really simple. Remember, everything stays the same, except those I strip those bars. Okay, 2x plus 4 equals 20. Right-hand side, remember, everything stays the same, except that this number becomes negative. And now I solve for x on both sides. Subtract 4 on both sides. This goes down. So we have 2x equals 16. Last step, we want x. We don't want 2x. So we divide by whatever number the x is attached to, which is 2. So now x is equal to 8. Other side now, don't forget about your part 2. See, I would have forgotten about my part 2, but I set it up so that I don't forget. Again, solving. Negative 24. again, we divide by whatever number the x is attached to. Okay. So, that is really that much it. Okay? Like, just do your best on this DCA. I just know the topics of what they're going to test you. I don't know exactly what problems like they're going to look like, but I do know that it's not me who writes this test, okay? So expect it to look different. All right? I just want you to try your best. I want you to do just try your best. That's all I can do. Watch the inverse video that I made like weeks ago. Watch the domain and range video I made weeks ago. Obviously, rewatch this video, okay? Before you open the DCA and before you submit the Unit 3 exam, okay? But you should be good at this point, so please just email me if you have any questions, and good luck. And 9 weeks down, 9 more to go before winter break, okay? So just let me know, email me if you have any questions, and I will see you guys whenever I see you, okay? And thanks for watching. Bye.